Hello, I welcome you all to this another interesting screencast, and the problem reads express the force as a Cartesian vector. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so I've been asked to express the force as a Cartesian vector. So we can work out this problem by using vector method or scalar approaches or combination of both. Okay, so we know that we need to find the position vector RAB. After that, we find the unit vector UAB, which is just going to be equal to RAB divided by the magnitude. And once we've done so, then we can have the force vector, which is just going to be equal to the unit vector times the actual force vector itself. Okay, so we'll be multiplying the force itself, this magnitude times the unit vector AB. So we'll have done the conversion, right? Okay, so we are not going to follow this. I feel it's a little bit lengthy. So what we are going to do is, of course, we are going to combine. It's a combined approach. We'll find the magnitude of AB. Later on, we are going to write down the components in all the axes. So let's start with first choosing our reference. For us, our reference is going to be equal to, the reference is going to be equal to A, and that will be 0, 0, 0. So let's draw our new coordinate system. So it is something like so, and then something like so. Okay. I haven't drawn it properly. Right, something like so. It comes up to there, something like so. That's good enough. Something like so. Great. I think that is good enough now. So let's call this as our y prime, our x prime, and our z prime. Great. So that's our reference. So let's look out for the coordinates. Let's look at the point B. So the point B in the x-axis. So let's write it down. So RAB, which is also equal to just RB because our reference is A, is just going to be equal to what's the coordinate in the x? Coordinate in the x is it is a what? That's this distance here from that's a 4 minus 2, right? Positive, so this is a 2i. You can see it, right? This is 2 here, and the whole length is 4, right? So it's 4 minus 2, and then in the y, in the y, it is a positive 3j. Then in the z, it's a 2 plus 4. Okay, this 2 plus 4. Okay, and this minus, since our reference is A, right? So minus 6k. Great. Okay, and what is the magnitude? Magnitude of this is just equal to, we just need this for now. Magnitude of this is just equal to that's 2 squared plus 3 squared plus minus 6 squared. What is this equal to? That's 2 squared, that's a 4, plus 3 squared, which is a 9, and 6 squared, which is a 36. So 49, which is a 7. The magnitude is 7. Alright, so let's write down the components now. We know that, let's start with the x component. This, we're going to have a component in this direction. Alright, and then we'll have another component in this direction. Okay, and then we'll have one component in this direction. Alright, let's label them. So this one is just going to be equal to this one is equal to let's call these forces just F. So this is F times the run along the x-axis, which is the length, and the length we said is just a 2. We're talking of this distance from there to there. Okay, this distance there. Okay, this distance. Okay, this distance, the position of B in the x-axis. So this is just F, which is 2 divided by the magnitude of RAB, or the hypotenuse, which is a 7. Okay, alright, so this is this one, and then this one here is just equal to F. What's the coordinate or the run along the y-axis? It is a 3, so this is just 3 divided by 7. You can think of these as unit vectors. These are all unit vectors. Okay, alright, and then we have this one. This one is just equal to F times what is the rise is a 6, right? 2 plus 4 divided by the hypotenuse 7. Alright, so we have everything. So therefore our force is just equal to F, the x-axis, that is a positive, the magnitude is 630, so it is 630 by 2 divided by 7 I plus 630 and times 3 positive also divided by 7 j, and minus 630 by 6 over 7 k. Alright, and then finally we have our force vector, which is just going to be equal to 630 by 2 divided by 7. This gives us a 180 plus 630 by 3 divided by 7. This is a 270 j, and then 630 by 6 divided by 7. This is 540. Okay. And the units for this is newtons. Alright, so what we found is a similar thing. So you can think of these as unit vectors. These are all unit vectors here, right? Okay. Alright, let's find the angles. So we have this one here and this one here. This is alpha. This is alpha. Then we have this one. This is beta. Then we have this one. This is gamma. Okay, so there we go. Maybe let me write this in another color. Okay, I think this is fine also. We can leave it the way it is. Great. So the unit vector IB is just going to be equal to is equal to RAB divided by the magnitude, which is also equal to F itself divided by the magnitude, right? So this is equal to 2I divided by 7 plus 3J divided by 7 minus 6K divided by 7, which is also equal to 180 I divided by 630. That's the magnitude of the force, right? Remember, the magnitude of this force is given already. It is 630 newtons, right? Okay, this is 630 newtons. All right, so this is equal to that plus 270 divided by 630 J minus 540 divided by 630 K. So you can use any of these. You still arrive at the same solution, right? So let's find cos alpha is just going to be equal to 2 divided by 7. Cos beta is just going to be equal to 3 divided by 7. And cos gamma is just going to be equal to minus 6 divided by 7. And alpha is just going to be equal to 2 divided by 7. Cos inverse of that gives us a 73.40 degrees. Beta is just going to be equal to 3 divided by 7. Cos inverse of that gives us a 64.62, and then gamma is just going to be equal to minus 6 divided by 7. Cos inverse of that, we have a 148.997. So when we round it off, it just becomes 149.00 degrees. Okay, so like I said, these angles we are not asked to find this. I just included them. All right, I guess we are done. We have the first vector. There we go. And then we have the angles. Of course, this we are not asked. It's just something that I decided to include. Alright, I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.